Back again. Hopefully it will work. What did we have? We have also calculated our theoretical value. So F theo of 220 and alpha equals 5% was 3.49. So somewhere here, F theoretical 3.49. So this area is then our 95%, and since 3.49 smaller than 70.16, H0 or the null hypothesis is rejected for a significance level of alpha equals 5%. And this we also find in our table. This I want to copy for you. 90 and 95. So let's cut this up to 20. And there we have it. So here 20 and 2, and then this is F theo, but of course now you have it always implemented in your software package in order to get this. And then we want also to have a look at the parameters beta itself. And this is then E. For E is the coefficient of the variable revenue. So revenue is beta 1. Significant now for a level alpha equals 1% if the standard error of beta 1 is 0.162. Well, and this means now H0 beta 1 equals 0, H1 beta 1 not equals 0 for alpha equals 1%. So graphically, we have again to calculate, so to speak, our empirical value. And now let's do it for pedagogical issues the other way around. T theoretical for 1%. So we will have for the T distribution somewhere here a minus T value. And since this distribution is symmetrical, the theoretical and the probability mass within these two tails then have to be 0.5%, since we want to have a significance level of 1%. So if now our empirical value deduced from the number 0.047 and the standard error 0.0126 is within this interval here, then we cannot reject the null hypothesis, and then we have to admit, well, although we find here a differing number from our from 0, then we would have to interpret this, well, this is only a statistical fluctuation for a level of 99% to be secure that it is differing from 0. So then let's go also at first into the table for the t-distribution. This we have from 7 on. So I think here we are. So what we need is alpha for a significance value of 1%. Since we have these double-sided tests, we then have to look at 0.995, and again, so we are in this column here, and unfortunately our t-distribution also depends on the number of data points and the number of parameters, and for the t-test we have then also to calculate n minus k minus 1. So this is again 23 minus 2 minus 1. And here we have to calculate the relation between our parameter 0.047 divided by the standard error as beta m. So then we are going back here. So this would be then t of 23 minus 2 minus 1 for alpha equals 1%, and this is then to 20. So we are here down here at 2.8453. Okay, so and let's do this also within Excel. Then we have equals t, the inverse function of 0.995 and 20, and hopefully my syntax is again right, 2.845, and this we have also here. So this is 23 minus 2 minus 1, and here 0.995, since we have a two-sided test. So this is 2.845, then this would be minus 2.845, and this would be plus 2.845, and now we have to calculate the empirical value, and this is, please, beta 1 over S. Beta 1 is 0.047 over 0.0126, and this is, so this would be T theoretical, and T empirical is 0.047 over 0.0126 is 3.73. Well, and then we are somewhere here, 3.73, and thus, since T amp is larger than T theo, 3.73, 2.845, we reject H0 for alpha equals 1%. Well, in general, you have to be a little bit careful if you have these two-sided tests, because then you should not just learn, well, if my empirical value is larger than, because of course, if we are in the region of minus, then the number has to be less. Quite often we compare, therefore, only the t value with the in absolute values, then you get rid of the minus sign. But I think if you have this picture in mind and you have a two-sided test, then you know I'm supposed to be in the right or in the left direction. And if you have the one-sided test, then you are looking only for rejecting the null hypothesis at one side of the interval. Because this, although we are not writing a classical exam within this course, this is then also quite often found in results in an exam that someone has only, is remembering, well, if it's larger than, and if then I have chosen maybe a task where you are in the minus part, well, then the answer is wrong, because then the number has to be less. Okay, so this we have, and well, now since we lost some time, we will not manage the last exercise fully today, because here I invented, so to speak, something new what I haven't done until now in statistic courses, and I don't know if it's done somewhere else, because I thought it would be once quite good if we one time really take a little data set and then going really through all calculations, and not going through all calculations by just feeding in the data, pressing enter and get the result, but doing it, so to speak, more or less by hand. And this will then take some time. And for this data set here, where we said that we have a company with 7 stores in 7 different cities, and that these cities have a different number of inhabitants, and our stores in our cities have also a different size. So in general, if you have a company and you want to sell something in a store, that you can think of, the larger the city is, the larger is my store. This would be maybe your idea, but of course we can also say that maybe sometimes it's not possible to find a good location for our store, and so maybe we have a larger city but we have a smaller store, like I did it here in this case from number 5 to number 6, for example. And then of course we can also make here a linear regression on the two variables, inhabitants of the city and size of the store, in order to get an idea. Maybe the next store I want to open in a city of 150,000 people, is it really a good idea to really increase the size of my store? Okay, and this we want to do if we really calculate this highly quotation marks complicated function, where we have to calculate some inverse matrices. Okay, but let's start another 10 minutes for today, so we can do it then tomorrow together. So for this, at first, and this, I also always want to show you how to get data out of the internet into your software package. So let's try how this data is then taken. If we just copy it, well, now it's going, unfortunately, not directly how you want to have it, but then also I will show you how you can get this, if it works, hopefully. Now it works, yeah. That we want to have it not in a column, but in a line. So here you have the possibility to just transpose the data. So we have this, and then 1.22 is just this line here. Oops. 1.22. So every 4 we need 1, 2, 3, 4, 1, 2, 3, 4, and something one have unfortunately quite often do by hand, author, or you are really good in programming. I'm not. I'm doing this if I need fast the data, then just by hand. And now we are almost done. But this data is then again, since this is our line, we have again to interchange columns and lines, and this is again done by transposing this data here. So now we have our data, and what we need at first is that we need x and xt. And this is just the matrix which gives us the dependence between our variable to explain, our revenue, and our independent variables. And let's go back. How did it look like? So this was this multilinear dependence we are assuming. This we have to do for every data point. So we obtain then these matrix description. So what we have to do is we have to just take the values for our x variables and we have to add a vector with only ones, units, because this is then due to our beta 0. Because behind beta 0 we can just think, well, this is beta 0 times 1. Okay, so first of all we need x. And x is then our ones up to 7. 1, 2, 3, 4, 5, 6, 7. And then the values of x. Oh, this is 8. One too much. So the next one is in order to obtain beta, let's maybe yeah, copy this also to our exercise. And we only need this one. Up, top, and suck. With this, we want to end up. This is our aim. So xt times x. This would be then the first step. Let's go back in here. Since we have x, now we need xt. And for this, we have the function, since xt is just the transponed matrix, m transponing and reading in our data. Oops, closing brackets. So we have now xt, and then I told you now it is formatted as a matrix, and then you have sometimes problems to read further in the data. And in order to solve this problem, for me, I just, let's take here a large T. For me, I just read out the data once that I have it in, yeah, usual data points. So this equals this, and then 1, 2, 3, 4, 5, 6, 7 down here. And now I have no problems in order when I further on have to read in the data of x and x2 if I use this one. Okay, then next step is xt times x. Xt times x. And for this you have also the function of matrix multiplication, and this is multiplication. The first array is just the first matrix we need. No, I need this one here, since this was the reason I copied it, semicolon times x, closing brackets, and then I have xtx. Again, I read it out. So, what is next? Well, I need the inverse. Next step, xt times x and the inverse. Well, actually a 3 cross 3 matrix, we could do it by hand, but it would take, I think, half an hour in order to obtain the inverse. So then the inverse this is then inf, the function, and also reading in our matrix, and then we have the inverse. This I also read out, because what else do I need? This inverse function I have to multiply with the transponed matrix again. So next step is xt times x minus 1 xt. This is again a matrix multiplication. Times xt, oh sorry, times xt, yep. So is mult of our inverse function, semicolon, times our transponed matrix. And the last step is we have to multiply this with the output vector y. So this has to be calculated, multiplied with y. And the last step is xt x minus 1 xt times y. So this we need also that we have read it out, and then that you see it times y. So multiplication, the whole matrix, and where do we find y? Y is just the vector of output numbers we have. So this one and this one. So then let's put it up here, or here is this. 1 minute left, please. So why did we have done this? Let's go back. Oh no, here it is. I have written it already down. Well, the three numbers we obtained is now nothing else than beta 0, beta 1, and beta 2. So this is beta 0, beta 1, and beta 2. Well, and that I'm really right, let's take now just the version reading in the data, pressing enter, and everything is done. And this is linear regression P, reading in the Y data and the X data. And since later on we also want, of course, when we want to do hypothesis testing and calculating correlation and so on, we want also this as output, and therefore we need here the next variables to be true. And pressing enter, and what we see here is this is beta 0 equaling this. This is beta 1 equals this, and this is beta, oh, other way around, sorry. This is beta 0. So beta 1 and beta 2. So this was okay now. The recording is still okay, and at least I can then upload